All right, today we're tackling a question that honestly sounds like it's straight out of a sci fi movie, but it actually comes from the absolute cutting edge of physics. And that question is the very fabric of our reality as stable as we think it is?
I mean, seriously, could everything we know, every star, every galaxy, even the fundamental laws of physics, just vanish in an instant? Now, this isn't some late-night philosophical debate. No, this is a genuine possibility that physicists are grappling with right now. And it all circles back to the most famous particle discovered this century. Okay, so what you're looking at here is basically a map of our universe's fate, and it's all based on the measured masses of two particles, the Higgs boson and the top quark. See that green area? That's the perfectly safe stability region. But that's not where we are. Nope. We are right here in this yellow zone called the metastability region. And what that means is that our reality, well, it isn't permanent. It's temporary. It's stable for now.
So, what exactly makes our universe so precarious? Well, the source of all this potential instability actually lies with the very field that gives our universe its substance, the Higgs field. You see, the Higgs field is everywhere. It permeates all of space, and it's what gives mass to the particles that move through it. You can think of it like this. After the Big Bang, the Higgs field settled down into an energy valley. But here's the billion-dollar question. Did it settle into the deepest possible valley? The data? Well, the data suggests maybe not. It might just be resting in a shallow little dip, while a much deeper, much more stable state is just over the next hill.
And this temporary state? Well, that's what physicists call a false vacuum. So let's go back to our analogy. Our universe is like a ball sitting in that little divot on the hillside. Yeah, it's stable enough for now, but it's not in the deepest possible valley. And if it ever gets pushed over the edge, it's going to fall to that true lowest energy state, releasing an absolutely enormous amount of energy in the process. And look, this isn't just some wild hypothetical idea. When you factor in all the quantum effects, the math predicts exactly what this quote says. There is a second local minimum beyond the barrier, and that barrier, that's literally the only thing keeping our universe from rolling down into a completely new, fundamentally different state of being. Now, for decades, this whole idea really hasn't kept physicists up at night. And why not? Because the odds of our universe actually getting over that energy barrier are, well, they're astronomically small. See, for the universe to make that transition to the lower energy state, it would have to do something called quantum tunneling right through that barrier. This is one of those truly bizarre features of quantum mechanics, where a particle can just spontaneously appear on the other side of a barrier it shouldn't have the energy to cross. It's like our ball on the hillside suddenly teleporting to the bottom of the valley. It's possible, but it is incredibly, fantastically unlikely. Just how unlikely are we talking? Well, the calculated lifetime of our false vacuum is a 1 followed by more than 100 zeros. I mean, that's a number so mind-bogglingly colossal, it makes the entire age of the universe look like the blink of an eye. So, hey, that means we should be perfectly safe, right? Just to really put that number into perspective, take a look at this. The universe is about 13.8 billion years old. The time it would take for a random quantum tunneling event to happen is unfathomably longer. So based on the standard model, yeah, we had absolutely nothing to worry about.
But what if that calculation is missing something? What if there's some kind of shortcut, a way for the universe to bypass that absurdly long wait for quantum tunneling? What if there's a faster, more direct path down to the true vacuum?
And this is exactly where some brand new research comes in, proposing a mechanism that could just dramatically alter this whole picture. The theory involves these hypothetical defects in the universe, things called domain walls.
Okay, so what are domain walls? A great way to think about them is like the cracks that form in ice as it freezes. Imagine the super chaotic, high-energy early universe. As different regions of space settled down, they might have settled in slightly different ways, creating these massive boundaries between them. They are, essentially, theoretical flaws in the very fabric of reality itself. And all this leads to a pretty simple but kind of devastating question. We've calculated how stable our vacuum is out here in what we think of as normal space. But what about the physics inside one of these cosmic cracks? Because as it turns out, what these researchers found is that inside a domain wall, the rules that keep our universe safe, well, they might just not apply at all. Okay. This is it. This is what they discovered. On the left, you see the energy landscape of our universe. That little white cross? That's us, sitting safely in our false vacuum, protected by that nice energy ridge. But look at the right. That's the energy landscape inside a domain wall. The protective barrier, it's just gone. It's completely vanished.
And without that barrier, you don't need any improbable quantum tunneling. The Higgs field can just classically roll over to the true vacuum. It's like our ball is no longer in a cozy divot on a hillside. Nope, now it's sitting right at the edge of a cliff. The fall isn't just possible anymore. It's immediate and it's inevitable. So the process would be, to put it mildly, catastrophic. A domain wall, a leftover from the early universe, drifts through a region of space. Inside it, poof, the barrier protecting us disappears. Instantly, the Higgs field falls to its true lower energy state. This creates a bubble of true vacuum. And this bubble, it would expand outwards in all directions at the speed of light, completely rewriting the laws of physics as it goes. Okay, now before you start to panic, let's be clear. This research isn't about predicting that the end is nigh. Its real purpose is something much more fundamental to, how science actually works. Here's why this is so important. Physicists have tons of theories that go way beyond our current understanding. Theories of everything. And what this discovery gives them is a new, really powerful stress test. Think about it. If your new fancy theory describes a universe that would be instantly destroyed by these domain walls, well, then your theory's probably wrong. This is how scientists eliminate flawed ideas. And really, this is just how science works. It's by finding new ways our universe could fail that physicists get a much better handle on the really precise conditions that allow it to exist in the first place. It's a tool for refining the search for the ultimate laws of the cosmos, not some crystal ball for predicting doomsday. Okay, so let's just recap the whole thing. Our universe seems to be in a temporary state, a false vacuum. We thought it was safe for an almost infinite amount of time, but theoretical cracks in space-time, these domain walls, could be a shortcut to disaster. Why? Because inside these walls, the energy barrier that protects us can just disappear, triggering an instant collapse that expands at the speed of light. But, and this is the key part, this terrifying idea is actually an incredibly useful tool for scientists, helping them zero in on the true nature of reality. And that really just leaves us with one final thought. It feels like a paradox, right? But maybe, just maybe, by discovering all the ways our universe could be fragile, we actually get closer to understanding the profound reasons why, against all the odds, it's been so incredibly robust for so long.